Okay, so as always, before we begin, are there any questions? Okay, so the plan for today, as I was just explaining, is the quiz is now up on the DataMind website. So let me hold on. Why is it not
Over kids grade?
sharing?
Story of my life, great job.
How hot is your mouth right
Really hot.
Okay. So on the DataMind website, if you go to homework, tasks, and deadlines, the quiz is after assignment 4. It's going to be due a week from today. And if you click there, it should be, it's a Word document. But I'm going to go through the basic tasks here, but I'll bring it up. So,
Why don't you use the opener right there?
pardon?
Don't question him, Derek.
So these are going to be the tasks, and I'm going to walk through the steps that you're going to be needing to do for this quiz.
I can use steps 1 through 3. Don't worry about it.
So the first step is going to be make sure you have Weka. It's going to help to have the latest version so that we can have the package manager included. Now on the computer I'm working on here, I'm gonna work on it until Monday because the reason the package manager didn't work is that we need administrator privileges for the packages to install. So we're gonna install the Weka, open Weka. And you're going to want to have, the only thing that's necessary for this quiz is to have libsvm installed. And that's what you're going to use the package manager for. If you want, there's a separate version, there's a built-in version of stacking in the base Weka system. There's a different version called Stacking C. You can play around with that as well. But that's not required. So what we're going to do, we've already covered the Explorer, right? Did I start the camera?
Yeah.
Okay. And what we're going to do today is talk about how to use the experimenter, because what your task is going to be is to compare different classifiers on different data sets. And not just compare, but we're going to use Weka to determine whether there's a statistically significant difference between different algorithms on these particular data sets. And you don't need to know how to do this because Weka is going to do the work for you.
Nice.
Okay, where it's a T-tailed, to basic T-tailed test, which we'll get to in probability and statistics later this semester.
Can't wait.
So what we're going to do, we're going to rank the performance of 5 different algorithms on 5 different data sets. We're going to apply the algorithms, each algorithm to all the data sets. And I'm going to show how to do that. And our goal is to obtain the overall best performance on the 5 data sets using those. So if you install Weka, or when on any computer where Weka is installed. So
C drive.
So when you go into your Weka folder, there's a file, Weka manual, and this will explain how to go through. So what you're going to do is I'm going to bring up Weka and go kind of through the steps so that you, in case you get lost, the manual will also guide you through it. So what we're going to do is go down. To, I think that at least on my version, the page was a little bit off. But experimenter, it says page 55. Okay, there it goes. That's page 61, but. So here's the experimenter, and I'm going to bring up Weka at this as well. And we're going to do a fairly simple version here. So the graphical version, in section 6.2, and let's bring up Weka. And basically what we're going to do, so the manual you might have by your side or might not, it's not that complicated. So what we're going to do is we're going to go to the second box here, experimenter. We're going to bring that up. And so let's go back to my instructions. So what we're going to do is we're going to choose 5 different algorithms, and we're going to use 5 particular data sets. So the data sets are all in the subfolder of your Weka. Too many. The data subfolder. So here are your data sets. The 5 we're going to use are going to be breast cancer, diabetes, ionosphere, soybean, and supermarket. And those are all in the instructions. So, and then you're going to choose 5 algorithms. But the 5 algorithms have to include BaseNet, so that's one of them. LibSVM will be another one. Your choice of an ensemble method, which is located under Meta in Weka. The most common ones you might be interested in would be AdaBoost and stacking, but you're free to choose another one as well. And some sort of decision tree. J48 is a really common one. That's Weka's version of an algorithm called C45. And then we're going to use the 5 data sets that I already mentioned. So we're ready to start the experimenter. So the first thing we're going to do, if you follow the instructions, is we're going to create a new experimenter. Oh, I don't have write privileges on this machine.
Awkward. So you can't do it.
So I can't do it on this machine because I have to actually save a file onto this machine.
Well, you should be able to save it to your X drive.
Okay.
So, computer,
There we go.
I know so much about computers.
And I'll just save it here. Let's just call it experiment 1. Okay? Thank you. And we're gonna use the default, we're gonna use, notice, we have 10 folds, and we're gonna do 10 repetitions of our experiment. And everything is going to be set the same. So the first thing we're going to do is we're gonna add all of our data sets. This should be fairly self-explanatory. We're gonna add breast cancer. I can't add libsvm, well, that's in the algorithm, but I'm gonna add diabetes. We're going to add ionosphere, soybean,
Supermarket.
and supermarket. Does this make sense so far? Pretty straightforward? Now we're going to add our algorithms, and I'm only going to be able to do 4 of these.
Okay.
You have a question?
We're picking the algorithms that we want to use?
You're going to pick 5 algorithms,
Okay.
but one of them has to be BayesNet, one of them has to be libsvm.
So you're picking.
No, now you have a choice of 3. But one of the 3 has to be chosen as an ensemble method. What else did I say?
A decision tree and.
A decision tree.
Okay, something else.
And did I specify the 5th one, or did I just leave that
I think
completely
we
open?
used the one.
C489 or whatever, C48.
and
So what I
decision-
said is, where is it? It's up here.
Number 7.
So it has to be a BayesNet, a libsvm. So of the 3, one of them has to be an ensemble method, and one has to be decision tree, and then the 5th one is any kind of algorithm you desire.
There were multiple BayesNet algorithms, weren't there?
Yeah.
Last time we did this?
Right, well, I'm gonna come back to that, okay? So we set up the experimenter to use cross-validation with 10 folds, 10 repetitions. So the experiment's gonna come in several parts. The first part is we're gonna use all default parameter settings. So we talked about how you can adjust the number of maximum number of parents in the BayesNet, right? We talked about adjusting parameters. For the first part of the experiment, you don't want to touch any of that. That will come in the second part of the experiment. Does this make sense? So, now we're going to add the classifiers. So I added new, we're going to choose, well, BayesNet. Pretty straightforward.
Wow.
I can't add, usually I'd add the libsvm is underneath functions, but because I didn't have the right permissions to this computer, I was unable to add that to this computer. But we'll proceed with the other ones. We're going to choose an ensemble method, which comes from the meta class. Any particular choice here anyone wants?
Let's go long, whatever that says, long.
Log it boost. Okay.
I like logs, BX equals A. Log base 2.
I don't want that. popping
Log
up.
base 2 1/2 is -1, no big deal.
It's not like you missed that last week.
Everybody shut up, you missed it too.
I was yelling at.
So there's logic boost.
That's not true.
So I'm going to press OK. A decision tree. Any particular?
LMT.
And
One more.
let's add another one.
Let's go with rules.
I think,
I like rules. I like lazy. Never mind.
well, what I was thinking was, let's add a multi-layer perceptron,
Yeah, that's super fun.
okay? So we've added 4 here, right? So far, so good. You can save, if you want to save this configuration of all your experiments, you can save that as a file as well.
Oh,
So that you don't have to load, once it's all loaded, you don't have to load it every time.
sweet,
Um,
great.
so notice we have setup, run, and analyze tabs up at the very top. We're now in setup. We've set everything up. Again, you could save this setup for future experiments. What we're going to do next is we're going to run it. So we'll press run and start. And you can notice down at the bottom, it's running on BaseNet right now, run number 7. So it's, you can follow what's going on here.
I've got a question. If we were to do more runs than 10, would that give us better results?
It will be more, it's not that you would get better results, it's gonna make it more accurate. The more runs you do, the averaging starts to be more averaging, or more,
There are less
Accurate.
outliers.
and
than
fewer
results.
outliers, less variation
Okay.
in your results. So, it should be, it's on supermarket, run number 10. So it's doing them in a different order than what we had.
That's okay.
But what we're going to be interested in is looking at the analysis at the end.
So now, in the analysis, you can look at each separate one.
Well, it's gonna give us, it'll tell us which ones are more, the first one we input is usually gonna be our base, upon which the others are compared.
Okay.
So we're gonna get a table, and you'll see it in a few seconds here. Comparison, it's gonna give you the percent of correct results for each of the algorithms that we ran. But there's more to what I have here, so hold on until we're done here. Looks like the soybean might take longer. So the downside of having more runs is it's gonna take longer, and as you can see,
Oh,
this,
yeah.
That's okay, we can use their Zeus
So
program.
is there a specific amount of runs that is optimal, or no?
that's Jeremiah's question.
Well, I
The
mean,
more
is that-
runs you get, and the averaging just makes
So
that.
there's not like a specific number?
No, I mean, 10, it's just one that, I didn't want to have it run too long,
But you wanted enough to get accurate.
but you want enough to get reasonably accurate
Okay.
data.
And
Right?
guess
And
what
this-
number's gonna
I didn't
be
expect
from base
on my machine-
set.
The soybean, and this, even with the 5,
Well, it sounds like your fan's running pretty loud.
I think this is a much slower machine than my laptop, so.
Yeah.
Well, it's not a Mac, so.
I am a Mac and I'm a PC.
So, I didn't, when I ran this in my office, it was much faster than this. So we'll just have to
Continue teaching while it runs.
wait.
How's
So I can go, while this runs, let's go back to what your tasks are going to be. So, again, we just set it up with default parameters, okay? And our ultimate goal here is, on those particular data sets, a ranking of the 5 that you compared, the 5 different classifiers. Now, if 2 are not statistically different from each other, then they're gonna be ranked at the same level. If that makes sense.
So it's
Even though one might say 89.5% and the other might say 90.3%, if there's not what's called a statistically significant difference, we have to rank those the same.
So they're kind of discrete, there's like intervals.
So you're gonna say this one's best, this one's second best, this one's third best, these two are fourth best, or something along those lines. Okay, that's what our goal is going to be, and Weka's gonna do most of the work for you. So you don't need to do the calculations by hand, right? And that's what this part here says, and we're going to, you're going to use a setting paired t-tester corrected. It's a default setting within Weka. Using percent correct as your comparison field, again, it's your default, and the default significance level of 0.05. And that's what's determining whether there's a statistical difference between algorithm A and algorithm B. So the results of the analysis will tell you when an algorithm is statistically better or worse than your base algorithm.
And we're always gonna take our Bayes algorithm as our control, I guess?
Whichever one you put in first.
Okay, so it doesn't matter.
So, I mean, it's not going to matter because you're gonna have to rank them, and we'll talk about that. While we still wait on Weka here, you're now, after this is done, after you've ranked all of these, and in order to do that, you might need to do pairwise comparisons. You might be able to make some comparisons by doing all 5 algorithms at once. You might be able to say, hey, look, the Bayes net is obviously better or worse than the decision tree I chose. Okay? But you might not be able to tell the entire ranking because you'll also say, well, so was the multi-layer perceptron was also better or worse than Bayes net. Well, now how do you compare the multi-layer perceptron and the decision tree, right? So you might have to do another experiment to determine if there's a statistical difference between those two. Does that make sense?
Yeah. How would you go about it? How do you?
Well, you could compare them side by side, just 2 of them. You could do, instead of doing all 5, you could do multi-layer perceptron and the decision tree, just compare those 2, and when you analyze it, you'll be able to determine whether one of them was statistically significantly better than the other or not. So you could do pairwise comparisons.
You could even just add up points. Like if you got first place, you got 5 points. Second place, you got 2 points. And just add up the points for each thing. It's 2,000.
Well, yeah, but you're not going to get that data. The data that you're going to get is whichever algorithm you have first. Algorithm A, algorithm B, is better. It's not going to say necessarily how that it's statistically significantly better than A. C is statistically significantly better than A. But do you know whether how B and C rank, whether they're statistically different, enough different, without comparing them directly?
So basically what you're saying is if we do all 5 at once, all we'll really know is which one performed the worst.
Or you'll know, well, we'll just take a look at it when it comes out.
In 4 hours.
So the goal is to rank them as best you can. Does that make sense? And hopefully, this is the tree classifier. Hopefully the other one's on this. We're on classifier 3. Oh wow. Now, I'm going to continue on explaining when you're done with that. Okay?
not run 8 or 6?
No, it's
8. It's classifier 3, run 9.
Nine.
Sorry, my eyes are so bad.
maybe you should put on your leopard shades.
Okay, for the next part of the experiment, your mission is to find amongst the 5 algorithms that you chose, you're gonna start playing with parameter settings. Okay? And you're gonna try to get the absolute best performance that you can. On the suite of the 5 data sets. Does that make some sense? So for example, if I could, well, the Explorer might actually be able to be looked at simultaneously. Yeah.
Nice.
So for example, if I were to open isn't it under here?
Mm-hmm.
If I were to open, what file am I going to look at?
Glass.
Let's look at like soybean or supermarket.
Or ionosphere.
Ionosphere, okay? And we're gonna classify and we're going to do a Bayes net. And what just happened?
You just bugged it out.
Well, you just
If
missed.
you change your
minimize
window, it's
everything
the only
else.
one that's visible.
That was cool.
You never knew that feature? Oh yeah, if it's the only window you want visible, just shake it around, everything will disappear.
Weird. I haven't used that either.
So it's on the supermarket.
I have a map.
Do you at least use snapping?
Okay, so we do the Bayes net and,
Totally from shaking.
so are we talking about the where were we?
We were talking about.
Now you know that real cowboy.
Changing parameters. So if you remember, I can click inside that, that box where BaseNet is in here. And we can click even inside here, the search algorithm. We can, for example, change the number of parents. If you remember doing that. Yes? And we changed it to, so here's your chance to play around with the parameters. And then you can, again, start it. Okay? Now, we're not gonna get this kind of output from the experimenter. Okay? But once you've done that, once you've found your absolute best, and maybe this is the best, it doesn't look like it would be the best, but over the entire suite, the next thing you're going to do is, so you're going to find the algorithm and parameter setting that provides the best overall performance as measured in the experimenter. So by overall performance, I mean not just on the soybean data set and not just on the ionosphere, but over the entire suite. You're going to find your best performing algorithm and parameter settings combination, and then you're going to write up a report to me with your findings. The findings being the rankings and the Weka outputs. And I thought I had a little bit more. Here they are. Your outputs from the experimenter for all comparisons should be shown. So when you use multiple comparisons, just copy and paste those values in your report.
Jeremiah, where did you find that?
You want to list the best overall algorithm, which algorithm, Was it BaseNet? Was it a multi-level layer perceptron? Tell me which algorithm gave you the best performance and what parameter settings for that algorithm. Again, copy and paste your results from the experimenter of the results of your best overall classifier and any additional information. So by that additional information, I gave an example in the instructions here. Remember, if I right click over here on the BaseNet, you can visualize, I don't remember the graph. Oh, this is a much more complicated example.
Woo, what is
Wow.
that?
This is the BaseNet that was used with a maximum of 3 parents
I don't like BaseNet anymore.
for the ionosphere example.
Wow.
Look at the
How
soybean example.
convoluted that thing got.
So,
Terrifying.
Imagine having
So
to do that
that's-
yourself.
that's gonna be part of your report.
What, that picture?
Yes.
Yeah, okay. You could just, that little flop.
How did you get that again?
Should save it.
Okay, how did I get that again? I right click on the result that gave me the best performance. And then it says visualize graph.
Oh, nice.
If it was a decision tree, it would show you the decision tree.
So that's the
Okay, let's
best
see all of them.
performance?
Oh, I don't know,
That was just the.
I'm just showing you how to get the information.
Well, let's go back to the other stuff.
Well, it's still running.
It's still
It's on
running.
classifier number 4 of 5.
Oh my gosh, Dr. Clay.
Well, my computer would finish this like in 5 minutes.
It was probably able to spit it out into multiple threads.
Can we use
And wasn't
Zeus?
able to advance.
Right. So maybe that was, I can change the data sets if it ends up being a problem.
Dr. Lou, can we use Zeus to run this, please?
That would be awesome. It really would.
I don't know if his microphone, because we're sharing the desktop.
Yeah.
So, talk to me. So what I tried to do with this quiz is kind of give you some experience working with Weka to actually do some comparisons among different classifiers. I chose 5 classifiers and 5 data sets because I thought that would give enough breadth so things would get averaged out without taking too long.
Should've went with 5 runs.
Pardon?
Should've went with 5 runs.
I can change that. If people have problems on their computers with 10 runs, we can change it to.
I'm just gonna do this on the supers, so don't worry about it.
Weka's not installed in there.
Where is it installed? I thought we installed it.
Not
In
on
the
the
Turing lab machines and in,
Tom would have installed it on the supers.
well, I don't have an admin account on the supers.
Dr. Clay, get him an admin account now.
No, you do. Don't you have an admin account around campus?
It doesn't work on the supers because the supers don't recognize the AD's user groups.
See, that happened that was a switch from last semester. Because Tom set it up so it would,
Tom had a local admin account that he logged into.
do you need me to give you an admin account?
That'd probably be nice.
And then you put Wek on it today, and then I can use it Monday.
Like, come on, man, Steam's on there.
I know you've got it in the past.
That is the
you
weirdest
need to-
thing. Why is Steam installed on it?
Minecraft's on there, thanks to me.
Oh, that's when I had Minecraft. I wouldn't mind that.
So,
Let's do a project, and it's been Minecraft.
Can we go- well, so I'm gonna, while we wait, because it's taking a lot longer than I expected. So let's cut the number of runs down to 5. So the number of repetitions will be 5, that'll speed things up by a factor of 2.
So if we do this on our home machines and feel like running it more than that, we can.
No, because I wanna have consistency
Okay.
across the quiz. So I'm gonna look here, so I'm gonna look, notice the configuration settings. Paired t-test corrected. We're gonna leave that alone. We're not gonna do anything really here at significance, 0.05. We're gonna leave that alone. You change that, that's going to determine the threshold between two different classifiers being ranked significantly different.
Okay.
And basically, what you're going to do is you're going to bring up your file that we are currently saving all of our data to. In the example that I did, we saved it on the X drive under EXP1 for experiment 1.
Okay.
And so we're gonna, before we do anything, we'll bring that file, select it, and then the perform test button down here will become available. Where is the other case that we have? The experimenter? Oh, it's right here. It's still running.
Wow.
It must be and I wonder if some of it's also writing to the X
It's possible. I mean,
the X drive, because that's going over the network.
Yeah. Is
Doubtful.
now?
No, it might be if everyone's using, especially if I think there are a few labs in this building. And if they're in use, then there's gonna be quite a bit.
Of traffic.
Yeah.
So the output, well, I can bring it up, not here, I think we're done with this. But here, the output, and because I'm waiting on it, but it will look something like this, and I'll try to bring it up. So where it's legible. They have an example of the output. Running an experiment. Where's analysis?
Could hold down control, hit F, and then type analysis, and it should be able to find it.
Right.
I'm just on fire. I did not want it to take this long, but yeah, that's.
Some people don't bring their laptops,
Well, let's see. I wonder if it's going to screw it up if I stop it. Should we try it?
It's not gonna hurt, I mean, we're gonna.
Let's see if I can bring up. Okay, premature end of file. So let's go back to the setup and maybe just take out the soybean. There's the soybean example.
Delete selected button.
Delete selected. And let's just do it on, say, 2. Let's do 2. Let's just do 2 and 2, right? Let's just do base net versus, and let's do 2 repetitions. That sound good? And so we want to save it, and we're going to start. Run. So this should go a little bit faster, right? And maybe we'll finish in time to actually
Classifier 2.
run one.
It might have been that multi-layer perceptron that was slowing it down.
No, it's not, it's using the same data. See that? It's still using breast, it was using soybean still.
Next time you just gotta screw it off your laptop.
Yeah, but then I can't. Oh, you know what I didn't? I didn't save this. Did I need to save it? Right. So it was continuing what we did before.
You didn't select the X drive.
Thought I did. Okay. And then we're going to start it. I can't remember which two we had.
Breast cancer and diabetes.
Breast cancer and diabetes.
Diabetes.
So hopefully it doesn't continue the old version. Did breast cancer take a long time?
No, I'm thinking it's that multi-layer perceptron that's taking so much time.
I thought it was the decision tree that was taking so long.
Uh-uh.
Well, we're on run 2.
Should we see this in the CPU usage?
Possibly, if you want to open up the task manager.
Let's just give up.
Well, basically, what you're
It's
gonna,
on, it's on run 1.
pardon?
It's on classifier 2, run 2.
What you're gonna see
Done.
is, you're gonna see codes next to the columns.
It just finished.
It just finished. Okay, cool. So here's file. Which one did it load it? Yes, it did. Perform test. Okay, here we go. So BayesNet is on the left and the function is on the right. And notice that there's no V and there's no star here. A V represents much better, statistically significant, better performance, and a star represents significantly worse performance. And notice we only did 2 runs, and notice even though we have almost 73% on the breast cancer and 66 for the other classifier for breast cancer, that was not a statistically significant difference. In fact, there is no statistically significant difference here. Down here, the 0 means of the two cases, data sets we ran it on, 0 of them were better statistically, 2 of them were the same, and 0 were worse. So statistically significant, in terms of statistical significance, these are identical on both data sets,
Both classifiers.
on both classifiers. That's what I wanted to finish on.
I like that. That's cool. Okay.
So that's how you're going to use it to help you finish.
All right.
That took a little bit longer than I expected. I mean, I timed it on my laptop and it wasn't anything close to what you were just looking at, right? So questions?
Before you go,
Daytona Beach?
or zero to quick.
questions? Does that seem doable?
Yeah, it's pretty straightforward, actually. I mean,
It's just time consuming computer.
We do, and it's time to hear. Can you hear me?
I hear you fine.
Yeah, the question, so from maybe you highlight the question on the top.
Oh, okay. Let me take a look.
I have answered it for you, sir. You answered it for me.
Since the.
Yeah, that could, I mean, basically, I mean, you're doing the same experiment. In answer to your question, you're not like if you're doing a numerical method and you're breaking in, say for differential equations, you're breaking your interval up into smaller and smaller pieces. Yes, it can increase your error. What Weka's doing is it's doing the same experiment. So it's going to just lessen the variance, right? Lessen the variation in your results.
Yeah, so it's more like running the same code over and over again, as opposed to running the same loop over and over again.
Right, but it's getting different, possibly different random sets for your cross-validation.
Okay.
Right, so you're not necessarily always doing it on the same training and testing sets. So there will be some differences, but overall it should just lessen the variation in your results, fewer outliers. And yeah, I mean, if you think about it, if you do it enough times, it's going to be limited because by the size of your data. Eventually, you'll get all the permutations and you won't get any, right.
Thank you.
Sure.
I guess if we have time, I do have one more question.
Sure.
I never managed to finish the last homework.
Yeah, just get it to me. I am so buried right now that you get it to me. I haven't started grading it.
Okay. Well, I mean, do you have a second right now? Or do you
Sure.
have to go?
Sure. I have to cover for a professor across campus, but that's easy. So just go for it.
Okay. My only question was regarding the probabilities when you're calculating the different change in information measures.
Right?
Basically, each one has you calculate a probability.
Right? So for example, is it how to calculate those probabilities?
Exactly. I'm typing it here. You have those types of probabilities, and I'm not sure exactly. The book wasn't exactly clear on what they meant, for those probabilities.
Okay.
And I kept getting measures that were outside of the range that it's supposed to be in. Like for the classification error, I would get an error greater than 0.5.
Okay. So here it is. So at each stage, the t just means at iteration t, right? So as you go down the tree, as you split on, say, Sunny, right? So I think I did that in the weather example. You have 3 yeses and 2 nos. Okay? So now what you have is a 3/5, 2/5 are your probabilities.
Mm-hmm.
And so what you'll do is negative 3/5 log base 2 of 3/5 minus 2/5 log base 2 of 2/5.
So for each one, you do both
Exactly, and add them, or, right.
Okay, see, I was picking one, and I was only using one of the two probabilities, and so of course I was getting all the wrong numbers.
Right, so a 3-2 split's gonna have exactly the same, information as a 2-3 split.
Okay,
Or if you have even more, if it splits into 4 or 5, you're gonna do the same thing, negative p log p, minus negative p2 log p2, and so on. But those probabilities, they're really having to do with the distribution at that level of your decision tree.
okay.
Does that help?
Yeah, it does, because I understood what their purpose was. It was just the nitty gritty of how do you
actually calculate it, right. Is that good?
Perfect, thank you.
Okay, sure.